Hi, in this video, I want to talk a little bit about, well, first of all, we're going to take a closer look at MAC address table and how they relate to VLANs, because we're going to trace the communications between two devices on the same IP network or VLAN. In the next video, we'll do it between two devices on different IP networks, different VLANs. Okay, first of all, a lot of times I get asked this question, do switches have a MAC address? Because sometimes people see MAC addresses in the MAC address table of a switch and says, that's not one of the end devices. Well, the answer is yes. Switch ports have a MAC address for control protocol frames. This is like spanning tree, spanning tree protocol, dynamic trunking protocol, VLAN trunking protocol, Cisco discovery protocol, link layer discovery protocol, and there's more. Okay, so for Cisco switches, they actually have a specific MAC address on every port. So it depends on the vendor. Some vendors will have one MAC address for all their ports. Matter of fact, if we look at the MAC address table of distribution 1 switch, we will see the MAC address associated on its gig 101 port right here that shows the MAC address of access 1-1. And again, this is because these two switches are sending these control frames between each other. Okay, so now that we got that out of the way, let's take a look at what happens when PC2 wants to send a packet to PC3. Well, first of all, PC2 recognizes as, PC3's destination IP address, that IP address is on the same network as myself. So I can reach it directly. I do not have to use a router. Okay, remember, devices live in a bubble. They don't see this topology like we see it. So the first thing that the PC2 will do says, so I know the IP address of the destination, but do I know its MAC address? So it checks its ARP table. And let's say it's not in there. So what it's going to do is it's going to put this packet and the Ethernet frame on hold, and it's going to send out an ARP request. So the ARP request goes out from PC2. Now, at this point, PC2 is just going to wait on the ARP reply. It just lives in a bubble. So access 1-3 switch receives it. So first of all, a little reminder on the MAC address table. Okay, every Ethernet switch will learn by examining the source MAC address of the incoming frame, and then the ingress port. So it's going to learn, access 1-3 is going to learn that on port, I think this is Fast Ethernet 06, that on Fast Ethernet 06 is this MAC address. I have it shortened here, but the full MAC address is right here. And it is associated with VLAN. Now, it also looks at the port that's assigned, the VLAN number that's assigned to that port, which is VLAN 20. So it puts all that information in its MAC address table. We'll see an example of that when we get to distribution 1 switch. Okay, so it says great, and now it's going to forward it. And it's going to say, hey, it's a broadcast. Now it's going to forward it out only, let me go back to this here. Because it's a broadcast, it's only going to send it out ports that belong to the same VLAN as the ingress port. Since this came in on a VLAN 20 port, this broadcast is only going to go out VLAN 20 ports. So which ports are those? Well, this Fast Ethernet 05 is VLAN 10. So the broadcast is not going to go out that port. VLAN segment broadcast domains. But this trunk link here does include VLAN 20. So it will go out this port here. It gets tagged by access 1-3 switch. So it gets a tag associated with it, and it gets untagged by the switch that receives the frame. So I can show that here, gets tagged, gets untagged. Okay. So again, as it goes, same process here with the MAC address table and the tagging. The frame gets tagged by this switch here, and gets untagged here. Now the frame is received by distribution 1. We can take a closer look at this MAC address table here. Again, every switch learns by examining the source MAC address, ingress port number, and port VLAN or tag. Because this frame came in with a tag associated with VLAN 20, and the source MAC address is 0B33, and the incoming port number was gig 101, all that information gets added to the MAC address table. Incoming port, the source MAC address, and this was the VLAN tag that was associated with that frame, VLAN 20. Okay. Next, these switches go into forward based on the destination MAC address. Again, broadcasts are going to go out all ports, but they're only going to go out those ports associated with that ingress VLAN. So this will only go out ports associated with this broadcast, will only go out ports associated with VLAN 20. Now, it will not go back out the port that it came in on, but this port here, gig 102, is a trunk port, and it does carry VLAN 20, so it is going to go out that port. So let's send that broadcast out there. It's going to go tagged, untagged. Okay, the process continues from this switch to this switch. Okay, we see the tagging and untagging there. Okay, now it is going to go out, the broadcast is going to go out this port here because it's associated with VLAN 20. Okay, it's also going to go out this port here, but it gets tagged. Remember, the tagging only happens on trunk ports. Trunk ports carry multiple VLANs. Did not get tagged going out this port because it belongs to VLAN 20. Okay. Okay, remember that came in tagged as VLAN 20, untagged, gets sent out VLAN 20, goes out here tagged and untagged as VLAN 20. We're almost there. It has now, the frame now goes out this port here, does not go out this port. This is a VLAN 121 port. So it's not going to go out this port. It will go out this port here because it is a VLAN 20 port. All right, now let's go back the other way. Okay, now PC3 is going to send back an ARP reply. It says, yes, you were looking for my, let me kind of go back there here. Okay, yes, I am 1021.101, so I'm going to send you back an ARP reply. Okay, so let's send back that ARP reply. So here's the ARP reply being sent by PC3. It's a unicast, so it's sending it from its source MAC address, but it's a unicast, so it's sending it back directly to PC2's MAC address. Okay, so let's go ahead and do that. It goes out that port. Great. PC3 says, I've done my job. Again, we go through this process of tagging and untagging. I'm going to talk a little bit more about the MAC address table in a moment. So there's the tag and untag. It's going to go out this port here, tag and untag. Now, by the way, the destination MAC address will be known by these switches. So it knows to send it out only that port. But let's talk about that a little bit more here. So here it gets tagged and untagged and received by distribution 1 switch. Okay, tagged, untagged. Okay, so again, the switch is always going to learn the source MAC address, in this case CBD2, abbreviated, the incoming port number gig 102, and the VLAN number. Okay, so the VLAN ID was 20, so that all gets entered into the MAC address table. VLAN 20, the source MAC address, the incoming port number. By the way, that's the same thing that happened on the previous switches. They did the same thing. They learned the source MAC address, the VLAN number, and its incoming port number. Next thing that's going to happen is it's going to examine the destination MAC address. Now, for destination MAC addresses, it's only going to consult its table with this for VLAN entries associated with the ingress VLAN. What does that mean? Since this came in on a port associated with VLAN 20, it's only going to consider its entries in its MAC address table that belong to VLAN 20. Oh, this one up here as well it would look at. Okay, so it would not look at this VLAN 10 entry at all. Yep. All right, so it sees, oh, okay, destination MAC address, that is in my table. It's right there. I had learned it previously, actually from the ARP request. I know to send that just out gig 101. And because it's a trunk link, yes, I am going to tag it as it goes out. Access 1-1 will untag it. And again, that same MAC address table process of learning and forwarding as we've seen previously. And that's going to go ahead and tag and untag. Okay, from this switch to this switch. It's going to get tagged and untagged. Again, tagged and untagged. Access 1-3 receives it, sends it out. Port Fast Ethernet 06. Again, it knows to send it out just that port, although there are no other ports on VLAN 20 because it learned it previously. Okay, we're almost there. PC2 now has the ARP reply. It puts that information in its ARP table, and it's going to use that information to then send out the packet in an Ethernet frame directly to the MAC address of PC3. So let's do that quickly here. So, okay, we know the MAC address of PC3, so let's just do this quickly. Okay, gets sent out by PC2. This is the packet, the original packet that we've been waiting to send here. Okay, again, tagged and untagged as it goes out here. I'm not going to go through the MAC address table, but tagged, untagged, tagged, untagged, tagged, untagged. Okay, but we'll look at it here. This switch here says, first of all, I need to learn source MAC address, ingress port number, and port VLAN or the tag. Okay, well, I already know about, let's see, here's the MAC address, source MAC address, right? That's already in my table. So it actually resets the 5-minute timer. Okay, next it's going to forward based on the destination MAC address. Again, because this came in tagged as VLAN 20, it's only going to consider its VLAN 20 ports. That's it. Okay, but it happens to be in there. The destination MAC address happens to be in there, right there, and it's VLAN 20. It's the only ones we consult. Gig 102, so I'm going to send it out that port there. Okay, tagged, untagged. Let's continue with this, tagged, untagged. I think you get an idea. And then it gets sent out to PC3, who receives the Ethernet frame with the packet. I hope this helped explain the process of how devices on the same IP network, the same VLAN, how they communicate. Very simple, just like devices without VLANs. Okay, the only thing that's really different here is the tagging and the additional information that we're considering with the VLAN ID when it comes to the MAC address table. All right, hope you found this helpful. In another video, the next video we'll do is we'll show what happens when a packet is sent between devices on different IP networks, different subnets. Thanks for watching.